We're going to deal with the last sequence of questions, so questions 11 to 15, and these are more related to organic chemistry, and I think a little bit with acid and base, but mostly it's organic chemistry. So it says classify glucose as aliphatic or aromatic. So there's no benzene ring in this anywhere, so it is clearly aliphatic. So there's no question about that. It's an aliphatic chemical. Which functional groups that you have studied can be identified in glucose? Well, glucose here has this group. Now, the C double bond O is a carbonyl. And carbonyls are found in esters as well as carboxylic acids. This group that does not have an OH, so it is not a carboxylic acid. But we do have hydroxyls here. And so they have alcohol groups to it. We would be probably not call this, well, it's not an alcohol, but it has hydroxyls. So that's a functional group as well. Those are our only functional groups in glucose. Glucose and fructose are isomers. What does that mean? Well, glucose and fructose have the same molecular formula, C6H12O6, but they have a different arrangement of functional groups and atoms. You can see that the carbonyl here is on the second carbon in fructose, but it's on the first carbon in glucose. So isomers have the same molecular formula, but have different chemical and physical properties. And as soon as I can see that they're different bonding structure, like the functional groups are in different places, it's going to definitely be not the same chemical. So they could be isomers if they have the same molecular structure. And it says here, starch is a polymer called a polysaccharide. So these it mentions here are monosaccharides. So we can make organic polymers in our in living organisms through condensation polymers. And what a condensation polymer does is it removes a water. And so it's going to be removing a hydroxyl somewhere and then a hydrogen from an adjacent molecule. So anytime it's giving off a water, it's called a condensation reaction. And so a condensation polymer would include polyesters, polyamides, like in protein synthesis. Would you expect a saccharide like fructose to be acidic? So here we've got the question is this acidic? And I'm going to assume that if there isn't a carboxylic acid end to it, that it is not an organic acid. And since this hydroxyl is not on the same carbon as this carbonyl, it's not going to be acidic. So I expect that an organic acid should have that carboxylic acid end.